welcome to Math Ninja Academy. So in this session, I will be exposing how you could have obtained 100% from semester test 2 without even sweating. So the scope for semester test 2, it was composed of 2 study units. Study unit 1, study unit 2, it was method of undetermined coefficient, whereas study unit 3, it was Laplace transform. So we'll be starting with our study unit 2, which is called method of undetermined coefficient. Under method of undetermined coefficient, in most cases, you will be required to determine what you call this, the general solution. You will be required to determine the general solution. And our general solution is given by y is equals to yc plus yp. One might wonder or question themselves, what exactly is this yc and what exactly is this yp? When we talk about our yc it simply means our complementary function. Our yc is our complementary function, and our yp is our particular integral. You will see in the next slide that we are having our yp and our yc. So this is the formula which you are going to use to determine the general solution, which is y is equals to yp plus yc. So don't get confused. One might wonder, what exactly, how can we solve this yc? How can we actually, which roads do we follow to solve this yc and this yp? So in the next slide, I will be exposing the cheat code that you are going to use in order to solve your yc and your yp. So you can see that we're having two pictures which are extracted from slides. We're having two pictures. The first one is this one. It represents your particular integral. And then the second one, we're having this picture which represents your complementary function. Complementary. So your yp, this is your yp, and this is your yc. So to choose your yc, you are guided by the value, by the nature of the roots. You are guided by the nature of the roots. You have real distinct root, you have real repeating roots, you also have complex roots. If you are having real distinct roots, this is your yc. You're going to use this equation here. Y is equals to ae to the exponent alpha x plus be to the exponent beta x. This is the equation which you are going to use when you are having real distinct roots. When you are having real repeating roots, this is the equation which you are going to use. And then when you're having complex roots, this is the equation that you are going to use for your what? For your yc. So basically this is for your yc. This is for your yc, which is your complementary. And then when it comes to particular integral, if you're given your right hand side, which is your function, as a constant, your straightforward case is going to be y is equals to a. If you're given your right hand side as a function polynomial of second degree, this will be your straightforward case. If you're given your right hand side, which is an exponential function, this will be your straightforward case, and so on and so on. For your special case, you just multiply the straightforward case by the independent variable. So without wasting more time, let's dive into the memo of the semester test 2 that we actually wrote. So question 1, it says write down the complementary function and a particular integral. I have mentioned that our method of undetermined coefficient, it gives us what? It is the sum of what? It is the sum of our yc and our yp, and I said our yc is complementary function and our yc is complementary function and our yp is particular integral. So from the question, they said we must write down the complementary function. What do they want? They want us to write yc, okay, and a particular integral and yp. So basically they're asking us to determine our yc and our yp. For each of the following second order differential equation, you can see what this is a differential equation because it consists of second derivative and an equal sign. Do not solve the differential equation. This is very important, guys. You are required to determine your yp and your yc, but they said you must not solve it. You just determine it and leave it like that. You are not asked to solve the differential equation. You are required to determine the yc and the yp. So without wasting more time, let's try to dive into the equation. So this is the differential equation which you were given: y double prime plus 5y prime plus 6y, which is equals to t squared plus 1. The first thing which you do here, you determine your characteristics equation, or what we call your auxiliary equation. So basically you're going to have what? M squared plus 5m plus 6, which is equals to 0. If you use the calculator, you will see that you're going to have m1, which is equals to what? Minus 2, and m2, which is equals to what? Minus 3. What can you conclude from the values of m? From the values of m, we can conclude that we're having real distinct roots. Real distinct roots. It means we're having real roots that are different in magnitude. We're having roots that are different. So our yc is going to be under what? Under real distinct roots. So this is the cheat code that I was talking about. You're going to look for your yc in this table. So you can see that when you're having real distinct root, let me just highlight it there. If you're having real distinct roots, it means that you're going to use what? This equation for your complementary function. What does this imply? This implies that your yc is going to be ae to the exponent minus 2t plus be to the exponent minus 3t. This is your yc. So we're done with the first one. And then they said we must also determine what? Particular integral. As I have already mentioned, that our general solution have our yc and our yp. Our yc, we use the nature of roots table, and then our yp, we're going to use this table which is written particular integral. So for our yp, we look at our right hand side. What type of function do we have in our right hand side? We can see that we're having a polynomial. We're having a polynomial of second degree. We're having a polynomial of second degree. What does this imply? This implies that we're gonna go to our particular integral table, which is this one, and look for a polynomial of second degree, and we can see that this is going to be our trial solution, or this is going to be our yp. So basically our answer for our yp is going to be yp is equals to what? Pay attention to something. Yes, you can see that here you are having your equation in terms of x and variable a, b, and c. But if you look at your right hand side, you're having a t. You understand? So it means it should be in terms of what? In terms of t, not x, because you don't have x in this differential equation. From the table, we are having yp, which is equals to ax squared plus bx plus c. But since you don't have x in this differential equation, so you are going to have at squared plus bt plus c. So this is your particular integral, and this is your complementary function. This is how you were supposed to obtain those 3 free marks. 1.2, we're still going to follow the same process. You can see even here we're given a differential equation. So we're still following the same process. The first thing which you need to do here, you need to determine the characteristics equation, which is the auxiliary equation, which is going to be m squared plus 4m plus 4, which is equals to 0. And then if you use your calculator, you're going to get m1, which is equals to m2, which is equals to what? Minus 2. Use the calculator to get the value. What does this imply? This implies that the roots for m1 and m2 are equal. So which table are we going to use for our YC? We're going to go to a table. When you are having real and repeating, you can see from the table that when you are having real and repeating, this is real repeating, m1 is equals to m2, which is equals to the value of m, which you would have obtained from your calculator. So basically it means you're going to use this equation, which is ax plus b e to the exponent alpha x. So our YC is going to be what? Our YC is going to be a plus, our YC is going to be ax plus b, yes. So it's going to be at plus b e to the exponent minus 2 t. You need to pay attention to something here. Remember, if you look at our table, it says our YC is equals to what? Ax plus b e to the exponent minus alpha x. But you need to pay attention to something here. In this differential equation, you don't have x, but you're having what? You're having t. That is why it's at plus b e to the exponent minus 2t. So for your YP, you're still going to do the same thing with what we did previously. You're still going to do the same thing. But if you open your eyes here, here's the tricky part. Always when you're having your roots which are twice, try by all means to simplify this further. Try by all means to simplify this further. You're going to have at e to the exponent minus 2t plus b e minus 2t. So if you compare your right hand side and your, if you compare your YC and your right hand side, you can see that you're having something here which is common. And if you're having cases like this, you're going to multiply your what? Your YP by t, because you're having what we call a special case. So you're going to multiply your YP by t. And now if you look at it, if you multiply your YP, if you multiply your YP by t, at the end of the day, you are still going to have something like this. For example, let's say our YP was supposed to be ae to the exponent minus 2t, and then we multiplied it by t. You can see that this part and this part, they're still the same. Understand? You're still having a special case. So in this format, or in this problem, we're going to multiply it by what? By t squared. So we're going to multiply it by t squared instead of multiplying it by a single t. So this concludes question 1. So by any chances, if you have questions or you do not understand anything, you can just WhatsApp me on this number. And the reference I used is the TT EMA 26B slide from Vojas. So that's it, guys. Please don't forget to like and subscribe for more videos.